Welcome back to my channel Conquer the Fear. Have you ever looked at the piece of Java code and thought, wait, what has happened to this particular program? If you are a Java developer professional aiming to master your coding skills, or if you are trying to prepare for the tough technical interview this year, then you have landed on this particular right video. Now, when it comes to Java codings, 90% of the developer fails right here itself, and they don't even get chance to move to the next level of interview process. Now, this video is going to give you chance to sharpen your problem solving skills. Also, it will give you the confidence to go to face your next challenge with confidence. Take the first example. The one which we are going to discuss is about the integer caching and double equal to operator. Now we are talking about auto boxing and along with the double to operator with the integer object. So we will discuss this particular concept over here of auto boxing. Now if you take a look at this particular example, here if you see integer is 10, 100, number 2 is 100, number 3 is 100. Now if you take a look at this, it is going to be a numbers written here and trying to compare it with the equality operator. Now can you tell me what would be the output over here? I will give you the explanation over here why. Now let's try to run this particular program first to show you what would be the output. Now if you take a look, the number 1 is equal to number 2 is equal to be true. Now this is same, right? But why are you wondering why this particular two numbers are not same, the number 3 and this number 4? Because number 1 and number 2, which we already discussed, is within the integer cache range. Now the cache range is minus 128 to 127. So that is the range which the integer cache ranges up. So the number 1 and the number 2 will refer to the same integer only. So there will be the object from the cache itself. Hence, the equal to method will require returns true over here. But in the case of number 3 and number 4, the 200 which is going to fall outside the cache range. So the new integer objects are created for both the double to equal to. So when you compare this particular double equal to, then it is going to return false over here. So that is the reason when it is going to fall the within the range, it is going to return the same thing. But if it is going to fall outside that particular range of 128 to 127, then this will return false over here. I hope like you are pretty blown up with this particular code and you were not even aware of this particular concept in details. Now let's take the second example. This is related to the immutability and the string pool concept. Now there is a difference between equal to and the hash code, double equal to and the equals method. Now if you take a look at this particular problem over here, I have written one string class with the string uh, hello over here, which is going to be in the string pool. Then second one also is going to have written as an s2, that is going to be the string pool. Now if you look at the third one, which is going to be the string, the new creation of the string. So this is one of the way where we create an string. Now the third is, and the fourth method is like we call this particular new string and then the intern over here. Now this will, what will happen with this particular intern method? If you are not aware, please check out my other video where I have actually explained in details. Now if you take a look at this is going to put that particular, now the method intern string dot intern is definitely going to put your uh, object into that particular string pool. So the in the heap there is a memory area called string pool. Okay, string constant pool. So in that it will put it. Now let's say if you're trying to compare these two over here, s1 and s2, which is this two. Now what would be the answer? This would be the answer true. Why? Because this is going to refer to the string pool. So if you see, this is the string literals. So according to the string concept, if there is already a string which is already present in the string pool, and if it is already there, this will point to this particular string one only. Then this is that is the reason, if you compare to these two things, it is going to the same memory over here. Now double equal to is going to check if it is a in the same memory, and if you see they are pointing to the same object, that's the reason it is showing as true over here. Now why it is different for this particular thing as a false over here is, if you see s1 and s3, now when you create a new object over here, will be created in the heap over here, and this will be created in the string constant pool. So that is the reason these two objects are different, and hence it will be different, and hence it will give you a new object of that. So that is the reason it is false. Now when it comes to s1 dot equals is equal to s3 dot equals, now this is going to return true only, because it is not checking the memory reference wherever it is pointing to, it is checking the content. So in this case, if this is going to be the same only, because the content is exactly same, it is not checking the memory reference or the address of it. So that's the reason it is going to check that. Now s1 is equal to s1 is equal to double s4. So whether this is going to be true or not, this is going to again refer to that particular same hello, because intern is going to put that particular value again if it is not present in the constant pool. Let's say if I had not written this thing, then it would have written this particular string intern, and then it is going to would have given you an value over here as a false over here. But here in this case, scp already existed, so hence it is not going to put that particular value over there, hence it is already existing, and hence it will return that. Now let's try to run this. Now you see, this is what I the expected, what we discussed. So hence this example is clear to you, right? Let us look at the most confusing question, that is finally, and finalize. And this is one of the important interview question asked by every Java interviewer, because this is one of the basics questions to confuse them. Now the confusion between these two is, it sounds very similar to it, but they have a different purpose to serve, and they have a different totally meaning to do. Now let's discuss what exactly. At the first, we'll discuss about the final, that is used for the variables. Now if you take a look at this particular variable, now if you see, this is x is equal to 10 over here. Now this is going to be the final variable. Now as per the string, or as per the final concept, once you assign that particular value, it cannot be assigned or reassigned the value. So even if you try to reassign this particular value, it is going to give a compile time error over here. Now let's say if I try to give you like this, now what will happen over here? If you see, this is going to give you a compile time error. That is the reason I have commented it, just to explain it to you. Now this is what exactly the final value, or the final when it comes to the variable. Then we'll discuss about the final when it comes to the block part. Now if you take a look at this, this is going to give you a try, catch, and the finally block. Now inside this particular code, whatever it is written, it will be executed no matter what happens. But there are some scenarios where this particular code can be skipped up, because let's say if something, uh, just for an example, if I say system.exit over here, now in this case this particular code will not be printed over here, because it will it will close this particular program here itself. If you want to see that, let me show you this particular code snippet and run this and show you. Now after this, you see, if it is after the inside the try catch block, it has not even executed anything. Okay, so the exception is not thrown. Let's say if I am trying to comment this out and see what would be the output. Now you'll see this will be other further codes would be executed. Now this is executed at any cost. So even though if it is going inside this, it will print. Now let me give you another scenario. Let's say some exception has occurred over here. Okay, and then you try to access that particular element over here. Then in that case, even after executing this catch block also, this particular code will be executed. So that's the concept of finalize. So this will be always be executed regardless of there is an exception occurred or not. Yeah, that is a different case when the program shut down itself, then you cannot do anything. So here if you see, let's say if I'm trying to make a garbage collection concept over here, now we'll talk about the finalize. Now if you see, there is one class object which we have created, and ultimately I'm trying to nullify it. Now this is going to make, let's say, the concept of garbage collection works like, let's say you have some strong references, and then let's say at the later point of time you have nullified and you are not trying to reference to any objects, then in that case you can go for the garbage collection. Although garbage collection is not going to be called up the moment you call it, because that is the work of the garbage collector to check out when it has to run based on the pause time and other algorithms it has. So based on the life cycle things, it will try to see, like, how the memory space it is going to handle and when it required to do that. So here if you call this gc, this is going to be the explicit calling of garbage collector, but it will not be a guarantee thing that it will run immediately. So in this case you call this particular thing, so in that case what happens, it is going to call this particular finalize method over here when we try to do this. So let's try to run this program and see how when this particular finalize method will be called. Now you see this is inside the finally block over here. So because I've called it as a null over here, so hence this particular object is available, and then our program also ended, hence it is got printed over here. So I hope I was able to explain you with a clear example of these three concepts over here. This is one of the tricky questions. Many of them fails to answer this. What happens when you try to you have a null and then you try to resolve it to some overloaded method? So in that case, how it is going to deal that? Now, if you take a look at this particular program, you see there are two methods of this particular class. But if you see the just the parameter is different over here, rest everything is same. It is static, void, and etc. Only the parameter it takes is object and one is in string. Now let's say what happens if I try to call this particular method with some null over here. Now can you tell me which one will be called out of this? Just take a look at it once and then think out of it, like, what would be the output of this. Let me try to run this and show you. It will always call this string method over here, because string is the most specific version of the which is related to the null. So when you're passing null to the overloaded method, it will try to find the specific method. Now string is going to be the more specific as compared to the object. That is the reason it is going to be calling that. Now if there were string buffer as an overloaded method, so then it would be a compile time error, because neither string or neither string buffer is more specific than the other than the part of the null. So in that case it could have given an error over here. Now if you try to see like this, now if you take a look at this, it is giving you a compile time error, because it will be a little bit confused about it where to call this, right? So that is the reason it is quite confusing over here. Now if the interviewer asks you such this kind of question, you can answer with the confidence over here. We are going to discuss about the array covariance. Now this array in Java which are covariant, let's say if you have some s as a type subtype and then t, if s is a subtype of a t, then the s of array is also a subtype of t array. That's the reason. But in when it comes to the generic concept, this is not applicable over here, and you will get a array store exception, which is going to be a runtime exception over there. Now let's say if you try to, if you take a look at this particular program. Now if you take a look at this object, now you're trying to do that, this is subtype of it. So if you take a look, string is nothing but a subtype of object, so hence this is okay. But when you see, you try to do the other part, like, you try to try assign an let's say you just try to do an individual assignment to this particular thing, this is still valid. But let's say if you're trying to store something, let's say an object which is an object over here of an array, and you're trying to store some string, simple string value over here instead of an array over here inside this, then this is going to give you a problem. So when a string is assignable to a string of array is assignable to an object array, you can directly store it in the object. whether it is null or object. But when you're trying to store an integer, which is going to be a non-string over here, then you will get a array store exception, which is going to be the runtime, because the underlining array is still expecting string of array. So this is the limitation of Java. Now let me try to give you this and try to run this particular program and show you. Now you see here, this is giving you an array store exception over here. Hence, that is the concept which can lead to an array store exception. So this is quite important, and many of them don't even aware of this particular thing, and they are completely blanked about it. Now here we are talking about the primitive type conversions and overflow. Now the implicit type conversions and the integer overflow or underflow, we'll discuss about it. Now if you take a look at this particular number over here, now this is calculates as an int first, because we are talking about as in this one. Ultimately, when you are trying to print this particular thing as an long without an l, now this is going to unexpectedly result an overflow of an int over here, because this is the huge number over here. Now first the big number calculation is going to be, int literals only, but the multiplication when it is performed using the int arithmetic, which can overflow beyond the result, is assigned to the long variable. So the L suffix on the 1000L is going to promote the entire expression to the long. So during this calculation, so this is going to prevent the overflow over here. Now if you take a look at example over here, so this is the correct way to deal with this instead of using this way. So if you assign this particular overflow value over here with the L over here, then there will be no overflow, so it will prevent from that. Okay, now if you're trying to add a character over here like this, now if you see I'm trying to do a sum of it. Now here you're trying to do the result would be the sum of this particular ASCII or the Unicode character values, because the Java literals are treated as an int over here in the arithmetic operation. Now I'll just show you this to run this. Now you see here, instead of this particular printing as an JAVA, now this is giving you an ASCII value, and this is going to sum up that particular value. I am sure that you must have got confused about this to be in Java as a simple answer to it, but look at the tricky part of it here out. This is an example of an max minimum, the double min value. Now this is going to be a misconception about the double dot min value. So when you're trying to call a double dot min value is the smallest positive non-zero number double value. So a very small positive number, not the most negative number over here. So that is therefore when you do 0.0d in that, it is going to indeed be the smallest number, and the output would be 0.0 only. If you take a look at this, the output will be 0.0. That would be the smallest number over here. Now, many of them are not aware of this particular mean value, what it exactly denotes, and how you can use it in your programs over here. Let's discuss about the checked and the unchecked exceptions in terms of overriding. Now, the rules of throwing the exception in the overriding methods are quite important. So you need to know about what are the overriding principles, what are the overriding principles when you're trying to throw an exception, especially in the overridden method. So now if you see, I have a parent method over here. If you see the method with the throw exception over here, now let's take a child example over here. You have one parent overridden method class over here. Now if you see, there are different combinations of things which I've done here. Now if you take a look at this, okay, so let's try to discuss the rules one by one. Now when you're trying to check this particular thing, now if you see, this is going to throw a more specific exception what you have defined in the parent one. Now if you take a look at this exception over here, but here if you see, I'm throwing the IO exception over here. So this is completely fine actually. So this will throw a exception over here. Now this is one of the overridden method. So the child class is going to be much more specific over here. Now when it comes to the rule of second, the second rule, you can throw an unchecked exception, that is going to be the unchecked exception or a subclass. Now if you try to throw this, let's see what happens. Now if you take a look at this, the method is already defined and it is going to throw a more specific exception which is already there. So this is going to be much more things actually. Let's say if I try to comment out this thing and I try to comment this as well, so there will be no problem because I'm trying to throw some specific exceptions over here. So you can throw unchecked exceptions over here in the parent child class over here. Now this is one of the second rule. Now the third rule, it says that you can also, if you take a look at this, this cannot throw a broader exception over here. Now if you see in the parent I have exception, but if you see throwable is the parent of the exception. So if you see the hierarchy is topmost now, so it cannot throw this particular exception over here. So that is the reason it will give you a compile time error over here if you try to throw this as an exception over here. So this is the rule number 3. Then let's see about the fourth rule. Now if you see, you cannot throw a no exception. Now let me and try to see here. You can throw here a no exception. Let's say if you define something over here as an exception and you're not throwing anything. So you can throw any, I mean, if you not define anything, that is completely fine over here. See here, it is going to throw the child method exception over here, and this is going to call over here only. Okay, so that's how you can use this. I hope you got the understanding of different overriding rules with respect to method overriding. This is related to the anonymous inner class using the this keyword. Now what this is going to refer is going to be the anonymous inner class. So when we are referring this with these things, then this is going to refer to the anonymous inner class. Now when you are using with Java 8 features, there is a lambda expression which is going to be reduced to need for creation of the anonymous class as a functional interface over here. Now if you take a look at this, you see the inner class created inside this particular anonymous inner class, and you see this particular reference, whatever you are trying to do, is going to refer to the anonymous class over here. Anonymous class over here. Okay, so this is going to be the inner field over there. Now if you want to access the outside class using the this things, then what you can do, you have to call it with the name of that particular anonymous class, then using this particular this and then outer field. So if you try to call this is going to be referring to the inner field over there. So this is going to be of the anonymous inner class over here. So this one will be referred instead of the this one. So that is the problem over here, and this is how it solves it over here. Now if you see here, whatever we have discussed is going to be very very important. So please go through it once again. If you are not clear about this, make sure you have this particular clear concept cleared up over here, because this is little bit confused about and many people are not aware of the inner class concept as well. Now let us try to take a look at the static method things over here. So there is a concept of static method hiding, which is not going to be an overriding. It's a different thing from what we are discussing as an overriding. Now many confused it about, like, overriding with the static overriding hiding. So let's discuss that part. Now if you see, I have got a parent static method. Now make a note, this is a static method, not a normal method. And then I have a child method, which is again a static method of that particular thing. Now in this case, if you see, the static method are resolved at the compile time, so the at the based on the reference type whatever has been discussed over here. Now if you take a look at this in the code over here, now you see the parent class is going to be, now everything whatever you see here is compiled at the compile time only, there is no exception. Now if you see the first thing, Here if you see, the parent object, parent object is a child object over here. Now parent reference and child reference over here. So these three scenarios, when you call this particular method display, there will be a different calling of this. Now this will call the parent static method because this is going to refer the parent thing, compile time. Now this is going to determine the child static method. So this is going to be no, this is going to call the parent over here because this is calling the object to, and then this is going to be the static parent method over here. So hence it is going to call this over here as a parent method. But let's say if you are calling the static child method over here, which is going to be determined at the compile time, hence this is the reason it is going to call that. But let's say if you're calling this particular display method, it will call the parent, it will call the direct over here. Now let's say in this case, let's say I could have hidden this example in this case. Now let's see what will happen. Now you see, these are the errors over here. It will not allow you to have this particular called up over here. So hence it is quite important when you understand this particular concept of method hiding. So these two things, whatever you see, it looks like an overriding, but it is an over hiding over here. Method, static method, we are trying to hide it from the parent to the child class over here. So this will only invoke the specific things over here based on the compile time, whatever it denotes. I hope I was able to explain you all the 10 tricky interview Java questions, which are the coding one. So if this video was helpful, please share it with the needy people. Also, don't forget to like, subscribe, and hit the bell icon. Thank you for watching.